Okay, so it's recording now. I'm going to share the screen. Okay, so it's recording and I'm sharing the screen. All right, so now we are on Brightspace. So let's go to the content section here. All right, so we are currently in this module, DNS, just wrapping it up. I've gone over the slides and I basically on Thursday went over how to set up bind, right? So we covered that in the whole class from beginning to end. And at the end, I showed you guys, we have a client server, a DNS client server architecture. And we saw how the client would use the DNS server and so on, right? So we got to the end of that. We completed that. Okay. So I'm going to open up the PDF document. So basically, if you remember, this is what we've been working on for a few sessions. I'll be wrapping this up today, basically, and then you guys should be able to finish up your homework. So we went over all of this, right? And we created zones and everything, and we discussed all of that on Thursday. We tested that DNS worked just fine. All right, and then we started the attacks. Remember, there are 3 attacks. The etc hosts attack. We also did this one on Thursday, so that's basically finished. And then, which is this one, modifying the host file. So that's where we kind of stopped on Thursday. So today we just have 2 more problems related to like DNS security and how DNS works, right? So we're going to do this one, directly spoofing response to user, okay? And you can see the architecture basically. We've talked about this a little bit before. Basically, the DNS client queries the DNS server for something, who is bank32.com, something like that. But you can assume that the attacker has done a denial of service attack on the DNS server, so it's down, basically, although you don't have to do a denial of service attack, just turn it off. All right, and then the attacker is going to launch its network spoofing attack, DNS spoofing. So effectively, the attacker will be responding to the user, okay? Any questions about that? That's basically the process. Now, there's a couple of ways that we could do this. We could do this with Scapy, which is we saw how that works, or we can do it with NetWalks. NetWalks is built more like in C, right? So it's faster. All right. This attack sometimes, some of these networking attacks may not always work with Python, just given that Python's a bit slower in its implementation, whereas they work, especially if like the DNS server was active, the DNS server might respond before the attacker does, you see? So that's kind of the issue. So basically, NetWalks is faster, and that's kind of what I'm going to show today, just the basic usage of it. And then you guys should be able to just replicate this in your lab assignment. Remember, you need to provide screenshots of it working and your understanding. Also have Wireshark in the background, capture the packets, okay? For each of these, notice we're using ping. So I think we use ping 1234 or something in the first problem. I do ask you to change the IP address for each problem, okay? So for this one, directly spoofing the response, just use another IP address instead of 1234, like 5678, something. And I'll show you in the example. And this is honestly, it's just for me when I grade, it's easier for me to like notice what's going on. And also making sure that you're not still using an older attack or something like that. Like you're using the etc host, for instance, because you forgot to change it. All right, so I just ask you to please, I'll check, but please just change the IP. Does that make sense? Like the pinging IP. Okay, remember, all we're doing in DNS is we have a mapping from a host name to an IP address, and that's it. We've covered all the theory. We're just really like wrapping up at the end. So this should be pretty clear. So in this attack, the victim's machine has not been compromised. That was the previous one where the etc host file was compromised. So attackers cannot directly change the DNS query process on the victim's machine. However, if attackers are on the same local network as the victim, they can still achieve a great damage, okay? When a user types the name of a website, such as bank or something.com in a web browser, the user's computer will issue a DNS request to the DNS server to resolve the IP address of the host name. After hearing this DNS request, the attackers can spoof the fake DNS response. So the fake DNS response will be accepted by the user's computer if it meets the following criteria, right? So remember, at the end of the day, it's kind of about understanding how this works. So the source IP address must match the source IP address must match the IP address of the DNS server. That's important, right? This is important because these are the parameters for the flags that are going to have to be in the networks attack. Remember, we are spoofing a DNS packet, kind of like I showed you in Scapy, right? So these parameters need to be correct so that for this to work. So the source IP address must match the IP address of the DNS server, right? As it's coming in back to the client. The destination IP address must match the IP address of the user's machine. The source port number, UDP port, must match the port number that the DNS request was sent to, usually port 53. The destination port number must match the port number that the DNS request was sent from. There should be a UDP checksum that must be correctly calculated. The transaction ID must match the transaction ID in the DNS request. The domain name in the questions section of the reply must match the domain name in the questions section of the request. Okay. The domain name in the answer section must match the domain name in the questions section of the DNS request. The user's computer must receive the attacker's DNS reply before it receives the legitimate DNS response. So this is what I was telling you. In the past, we've had issues with this lab because, Scapy may be slower, so you have to be really fast when you do it. But in this example, you're disconnecting the DNS server, so it should be fine. All right, now one great thing about this is like Scapy or NetWalks would just grab the packet, right, copy it, and then flip some parameters. So therefore, a lot of these we have already because we're going to sniff and spoof the packet, okay? So that's kind of what we're going to do. So this gives you the overall, the usage of the NetWalks tool 105. So if you remember, I showed you guys some time ago about this tool. I think we installed it on our VM. So today I'll just kind of show you the basic idea of it. Okay. So remember the setup is you have a DNS client, a DNS server, and the attacker. So at least 2 VMs, possibly even 3 VMs. It's useful here to write down the IP. So I'll demo this. Okay, and then the second attack is going to be the DNS cache poisoning attack. So this is the other one where you leave the actual bind9 DNS server on. Okay, it's enabled. Your goal is the attacker is actually attacking the DNS server itself. It's trying to insert something in the DNS cache of it. Okay, so it's a slightly different attack in concept, although the basic parameters are actually very similar. Okay, so this is also what we're gonna do. I'll run some commands for it, and basically you can see it's describing a lot of the things that I will demo, and that's it. Okay, so if you do these two, just remember in the background, run them, run Wireshark, etc. Okay, so we're gonna start with the demo. I will need to start 2 VMs. can follow along if you'd like. So we're still starting. So we'll need to write down the IP addresses. So, I suggest you take out a sheet of paper, you draw like 3 machines, get their IP addresses. It'll just make it easier for you. Okay, so let's go ahead and get started. Remember, they have to have individual IPs. You need to be able to ping from one to the other, and it's recommended that they be in that network. One. All right, so we got one machine here. And the other one. So I think on Thursday, Ubuntu 2004 was the client. And the IP was 10.0.2.4. So let me just confirm that that's the case still. Okay. I have config 10.0.2.4. Okay. Now let's go to the other machine. So Seed 2024 was the DNS server. I have config 10.0.2.15. So the IPs have not changed. So we know that we have this basically going. So let's go to client 10.0.2.4. So let's do. So let's do a dig of 10.0.2.1.2. I believe this is one of the either the email server, DNS server, something that we set up in the zones and the reverse zone, in fact. So if I do that, mail, right? mail.example.com, that tells me that we are using our DNS server. So the DNS server is up and running. Does that make sense? Questions? All right, so we can try another one. Yeah, this one. So WW 10.0.2.1.101. All right, great. So the client is using the DNS server. Should be able to ping Google. There it is. It's pinging. Make it a little bit bigger there. All right, so that's clear. All right, the etc host file, I probably left that 1234 in there. So what's going to happen if you ping 1234? It's defaulting, right, to the etc host. This is why I'm asking you guys to use different IP addresses for each of the 3 problems. Make sense? All right, so now let's go ahead and think about this. So we need to do what? We need to turn off the DNS server. So that's C2024. Okay, clear. So if I do netstat -na pipe rep UDP, right? So I got port 53 in there. So maybe I'm going to try to do sudo service bind 9. Stop. Okay. And that's that -na. And you can see I see fewer things in there, right? So now I'm going to go back to the client, which is Ubuntu 2004. Kind of repeat some of these things. Still ping Google. See if I can ping the DNS server. Got to answer. I don't see an answer, right? Do you guys see an answer? Let's try another one. www. 90, yeah, so 93, right? But it should have actually returned what? 10.02.101. Yes. So what does that mean? It means that the DNS server is off, correct? Do you guys see that? It's just using like the school's resolution. All right, but the DNS server is down. Okay, so now I'm going to try maybe mail. Yeah, so I don't see a response there. Okay. So that we turned, and that's because we turned off the DNS server, right? So any questions about that? Nope. All right, so now let's actually, for convenience, I'm just going to use the DNS server as the attacker because I only have 2 VMs. Okay, so the idea is that I'm going to launch a, somebody has done a denial of service maybe on the DNS server. It is just out of the picture. So now there's only DNS client, which is running dig commands on mail, www, etc., and it wants to get a response or something else. Okay, like bank 32. So maybe we're gonna try, for instance, I want to ping. What could I ping? I'm going to try to ping ryanbank24.com, right? So I'm going to do ping. This is what? Yeah. So this should be the client, right? Believe. No, sorry. This is DNS service. Let me go to the client. Here. This should be the client. Seed Ubuntu. Yeah. So I'm going to ping www.ryan. This is something that shouldn't exist. Ryan Bank 24. All right. So try it again. Nothing, right? So the DNS server would be in charge of, if it doesn't know what this is, provide the resolution, get the IPs and everything, right? Or we would query the www.example.com. So in this case, what I'm going to do now is I'm going to launch the attack, the sniffing and spoofing attack on NetWalks. We could also use the SCAPI code. That would have been possible. All right, and then basically we would get a response. This is similar to the example we did where we got the ping. So now we're just doing the DNS, and you get the idea. Remember, please have Wireshark in the background so you can capture all the packets. All right, so we're going to launch this attack from the DNS server. So that's going to be C2024 over here. All right, so I'm going to go ahead and clear this one. All right, so this is important for you guys to get this homework done, right? So you need to do the NetWalks tool. Remember, this is a very versatile network attacks tool in the command line. You also have a version called NetWag, which is GUI, so you can launch that one and play with it. So I'll give you the flag. So the attack is 105. So this is a DNS type of oh yeah.
Is this on the client for the?
That's a good question. So on the attacker. So because I don't, I keep saying have 3 and I only have 2, but if you had 3, I would recommend having a client, a DNS server, and an attacker. Since I only have 2, I turned off DNS server, right? And now I'm using DNS server as attacker. Do you see that? So I'm launching it from there. Got it? Yeah. Good question. All right, so I'm launching this from attacker. So I'm just doing sudo netwalks 105, and then I'm going to basically need to know what they're querying, right? So that's kind of the idea, that they're querying a bank. So you're going to supply the IP address for it. Remember that the server doesn't actually exist, but the ping should get a response of the IP that we want it to get. So in this case, I'm going to do -H. And I'm going to say that the domain that the entry basically is that bank 30, Ryan Bank. So Ryan Bank 24. Bank 24.com. All right. So this is one of the fields that needs to be in there with a -H. Then, and don't forget the double quotes. Let me expand this into it. Okay. All right, good. So then I'm going to add another flag, which is -H. All right. And this is, if you think of how we did this in SCAPI, this is just the fields and the headers of the packet, right? And the individual fields, that's all it is. All right. So I'm just trying to make it simpler for you. So we're going to use that -H, which is the actual IP that we're spoofing or man in the middle, whatever you want to say. The attack that we're doing is really here because we want them to go to this. So I would suggest just use another IP address. Again, just so it's easy for me to know that you're not still using the etc host file. Then you're going to say -A. If we what I read in the PDF, you also need to say that it's coming from a domain server, right? That they recognize, the DNS server. So then you're going to say -A, double quotes, and you can write in here ns.example.com. Remember that? Oops, sorry. That is the DNS server that we configured on Thursday. ns.example.com. Okay, then we're going to add the IP address -A of that DNS server, which this is why I said for this lab, take out a sheet of paper, write things down. It just makes it easier for you to remember, because otherwise you'd get really confused. So this should be the IP of that DNS server. So in my case, that is 10.02.15. You see that that's what it's expecting. So then I'm going to do 10.02.15. like that. Got it? So I just wrote that down. And remember, all the other fields, netwalks, because it's sniffing and spoofing, it just sniffs the packet, copies it, flips it, and then it just fills in what is necessary. And then the last part of this should be the -F, which is just a filter. And we're going to say here where the source, SRC, should be the IP of that client. All right, that's what we want to do. So the client in this case for my situation is Ubuntu 2004, which is 10.0.2.4. Right, so I'm just going to say here 10.0.2.4. All right, and hopefully this will work, right? So I'm going to launch this attack basically in a loop. So I'm hit enter here. Next, what netwalks command not found. Okay, so what does that mean? I haven't installed it yet on this machine. I think I did it on the client actually last time, probably. So then probably just sudo apt-get install, but let me just confirm. Yeah, do sudo apt-get update. Do that one, because this is a new VM for me this semester. Give it a minute. All right, it finished. All right, that's great. So I'm going to do clear here. So now we did the update, right? So I need to do now sudo apt install networks. Okay, hit Y and enter. So these should be running in C, I think, so it should be pretty fast. All right, so I believe it's finished now. Okay, so we are on C2024. Yeah, I'm launching it from here. All right, so I'm gonna just do a clear here and kind of repeat the attack command, which is this one. This was reported. Remember, I'm just doing up arrow. All right, so I hit enter. Notice it just hangs there. That just means it's running in a loop. And there it is. It's sniffing and spoofing. So now I need to go to the other machine client, which is Ubuntu 2004. And I'm gonna do Ryan 20. Okay. All right, should have worked. This is client, so let me ping. Yeah, I can reach it. Oh, no. Wait a minute. Ryan Bank 24. Do you guys see anything? This should be it, unless I'm making like a mistake. Do you guys see anything I'm missing? Did any of you get it to work?
Mine looks the same.
Huh? You're getting the same output as me?
I think I'm getting something.
Are you
Yeah, but I-
getting in the ping, the IP that I,
pinged, Ryan Bank 24, I did 5678 as the address, and I got at least,
the one response that said 5678?
yeah, 5684 bytes out of data.
But the IP is really what matters.
Yeah.
Are you getting that IP?
Yep.
Yeah, so I must have something.
Well, what I did beforehand was I edited it considering I have the DNS server as the attacker and my client as the attack.
Mhm.
I had the conf file, the one that had the hosts edited.
ETC host?
Yeah, the one that had the 12434 IP address.
Yeah.
I removed that before I tried it again, then it worked. So I'm wondering if making sure that's clear is what needs to happen. Because every time I pinged Ryan Bank 24, I would get like a message besides just the normal ping failure saying it like code, the .com file was wrong.
That's an interesting, let me just look in there. I can't foresee what would be the problem with that, but ETC host. Yeah, I had bank 32. This is why I'm using Ryan. So it should be a different thing, and it's not here anywhere. It shouldn't be this. Let's see. Ping Ryan Bank. Ellipses. This is running in the background. It's getting, so you can see on, this is C2024 is the DNS server. I can see in here is getting Ryan Bank, adding this PNW thing there. I think it's the DNS server of the university that might be doing something here. See, the 6286. Let me just try something. I'm just curious, to be honest. What was that? pnw.com? .com pnw.edu. This is running in the background. See, this is where Wireshark becomes useful, right? So we're going to have to debug to figure out why it's not working. All right. We need to see. This is still running, I believe. Okay. I'm going to run the ping. Ryan Bank 24. Two 521. 10.0.2.4 is pinging. It's these ICMP packets here. Hmm. Gonna dig W. Oop. Dig. I meant dig. See here in the dig command, I'm getting the response. Do you guys see that? Answer section, Ryan Bank 24, 6286, right? Do you guys see that? But the ping should also work. So that's what's throwing me off. Dig Ryan Bank 24. The NetWalks replied, spoofing, saying it was 10.0.2.15. There it is. And giving 6286, everything. So, but the ping, I'm pretty sure. All right, so we're gonna have to work through this problem. Let me take a look at the client configuration. I'm suspecting it's something with the university's DNS. It's much faster maybe. So all right, so adding the DNS server to the resolver configuration. Let's go to, I'm just going to check the configuration of a DNS client. So I'm going to CD into etc. CD into resolve conf plus CD into resolve dot conf dot D. Once. And then it's the head section, right? So sudo nano head. Okay. Name server here should be 10.02.15. Then let's do sudo resolve conf dash u. Okay. I'm gonna disable the firewall. This is Ubuntu 2004, the client. I'm also going to disable the firewall here. Sudo ufw disable. Run the command sudo netwalks 105. Ryan Bank 24. 6286. 10.02.15. Source is 10.0.2.4. It's listening. Okay. Client. This works, but not the ping. You said you got it to work. What's your name?
Matthew.
Do you have anything different from what I have that you can see? You got the ping to get something here, right?
Yeah, I got the thing to get something. Which command did you just run to get that output?
Just ping. Ryan Bank 24.
All right, well, now it's not working. It's saying the service is unknown.
Okay, so you are getting the same thing.
Well, it worked before,
Yeah, yeah.
but I've kind of just done other things, and even though I didn't stop the command, I just kind of was paying attention to the VM. So.
Mm-hmm. Okay. It's getting a resolution from the universities. How do I turn off the internet? All right, I just turned off the internet, I think. Right, so ping doesn't work now, right? So it's not using the school's DNS. And network. Okay. Mm, mm. All right, let me start the DNS service again. Let's just work our way back. All right, so this should be sudo bind 9 restart. Okay. So netstat. All right, everything's up and running. And go over here. Just gonna ping www.sample.com. Name. Okay, so it's not resolving either. Should be resolving, right? If it's the client, this is the client. Ubuntu 2004. This was working a second ago. Right. Okay, so this resolves. Okay. And there it is. So, yeah. What do you guys think? How do you interpret this output? Is there so obviously we haven't been able to reach Ryan Bank 24, right? That's our struggle for the last 10 minutes. There is no, in fact, such thing. But after praying a little bit, I was able to get by pinging Ryan 24, I was able to get 6286. Where did that come from? From NetWalks, right? It didn't come from the DNS server. It wasn't coming from anywhere. It just came from NetWalks. So maybe the school, I'm not saying this is the answer, but I do think you saw that when I took down, and you guys use your own judgment, right? Help me out here. We took down the DNS server, right? But when I would ping Google, I would still get ping replies, right? So that probably meant that it was using the university's DNS server, correct? In the background. Maybe what was happening is the school was replying faster than NetWalks. And just now, this came. Do you see what I'm saying, guys? That's a possibility. So, but this is basically what you guys need to replicate. Are you able to replicate this? Have any of you have?
Yeah.
Okay, great. Guys, Bob? Not able. Yeah, so what I did, I mean, the recipe that I can tell you is I did turn, actually, interestingly, the DNS server back on, but the DNS server does not have this entry, right? Do you guys agree? So the response came from NetWalks, which is the only one that has that in there. Does that make sense? But this is the screenshot that I'm looking for right there. You need to provide this one. You can put your own bank, like you could say, you know, Bob Bank 24 or something, and then just make sure that you get the IP that you requested. Do you guys have questions on this? So network attack, I mean, questions? Is it clear for everyone? You got to play with it, right? But yeah, that's kind of the idea. Have Wireshark in the background, do your research. And you can see here it provides information, the 6286 and so on. All right. Is that clear, guys? No? Yeah. All right. So this is what you have to replicate. Okay. It's a network attack, as I said. I mean, we can try it again. I mean, so let's say the only thing I would try is like change the numbers, right? So I'm going to say 7 and 7, you know, something like that. 7287. Ryan Bank 24. It's running in the background. Okay. Play with these, analyze them, break them up. The tutorials will show you a lot of details. Basically, it hasn't really. You can see it hasn't spoofed the packet yet because there's nothing going out here. Oh, something went out. He's doing some checks in there. Okay, so I'm gonna kill it. Try it again, maybe. I don't know if it's an issue of being faster. Oh, no, I did dig. Sorry, I did dig. Example.com. So if I do dig of Ryan, oh, this is a good thing. Yeah, I can do dig of Ryan 24 bank, and we'll see that we get I guess we didn't get the IP this time. It didn't change the name. Yeah, I feel it's using some other server, so isolating this from the network might be good. Okay, so ping 24. I get, oh yeah. So the trick that you can do is just turn off the internet on your laptop, right? That's what I haven't been. If I turn the internet on my physical laptop off, turn it off, then I'm no longer connected to the school. So there's no way that the school can.
I just tried that and it's still not working.
It's still.
But I'm seeing in the terminal stuff for the network command, it's still saying pnw.edu on there.
Yeah, give it a minute though. Like sometimes there's a delay, a little lag, so give it a minute. But that's what occurred to me just now when I try to turn off the internet on the VM. Actually, what my brain was trying to tell me is turn it off on the physical machine. Disconnect from DNS servers outside and constrain it a little bit more to your environment. Okay, and that should hopefully. If I do that, I'm going to break the SUM. I think, but this is running in the background. Try it again. I mean, Ryan Bank 24 7287 and this. I mean, these are the right parameters, I'm sure. We did get it to work once. But I do think maybe that might be the way to go. Try it without. Trying to do the dig command. See, it's got this VeriSign, it's got there's something going on there. Gonna do that. All right, so I'll read up on this a little bit more to see if I missed anything, but I think honestly, if you disconnect from the internet, hopefully, and keep trying it, you should get the dig, right? So that one we were getting before, and then but try to have that ping. Any questions, guys? Did anyone else try it? No luck.
Just restarting both my VMs now.
Restart, yeah, restart them, see if that works. All right, let's try the second problem, just so that we don't run out of time, and then you guys can play with this. We can touch on it again on Thursday. But as I said, make it a challenge to yourself to get that ping and the dig as well. All right, so now let's go to the second one. The second one should be similar, but now the attack is to the DNS server itself. So what I'm gonna do is here, the DNS server is running. We're gonna change the IP to something else. So this is called a DNS cache poisoning attack. So the DNS server will be on. So I'm gonna go ahead to the DNS server. I'm gonna kill this for now. Do clear here. And we're gonna empty the cache. So that should be sudo rndc flush. Okay, so just empty the cache, run Wireshark in the background. Now, basically here, we're gonna change the domain and also the IP address. Okay, so for this problem, and it's the same thing, we're gonna try it out with. Yeah, you have a question, Bob?
No, it's kind of small.
It's small. That's okay. Is that better?
Thank you.
All right. So in this example, we're going to poison the DNS server's cache. I'm going to do the attack from client because I only have 2 VMs. So I've emptied the cache, right? This is C2024 is the server. So I'm going to go to the client and launch the attack from there. Clear here. Just going to ping again the DNS server just in case. Yeah, so I can reach it. So it's not an issue of that. All right, so I'm going to go ahead and run the attack. So it's similar to the previous one. You do sudo netwalks 105 dash lowercase h. Change the domain for this problem so that, it doesn't happen because of the previous one. So I'm going to call this one Nathan Technology 76. Again, the logic here is that websites that don't exist, right? We don't actually want them to get resolved. You can do whatever you want here, Nathan. Technology 76.com. Okay. So this is what you would dig and ping, right? And hopefully get the cache spoofed or poisoned, as they call it, version of it. Then I'm going to do the actual IP that I want to get is a different one. So this one's going to be 8.0.4.2. Okay, so that's what we should get. Dash A is the it's ns.example.com. This is the domain, the name server, right? This is gotta be it. So, and then the IP for it, yeah, it's 10.02.15 for my setup. You have to use your own IPs. Remember, guys, in your command, use your IPs, right? Right, so then it should be 10.0.2 minus 15. The filter, same. Filter is source. So it would be 10.0.2.4 for me. Well, here I think it doesn't matter. Yeah, go ahead.
This one's on the client, not on the.
Yeah, that's a good question. I'm running it on the client because I'm targeting, in theory, the DNS server. Yeah. So they would all be from the attacker, basically. But so this source 10.0.2.15. Yeah, it should be the client here. Okay, so 10.0.2 10.0.2.4. And then this is new. So add the dash S raw minus T 600. Okay. So this is what what we need to add. And now this command should poison the cache. Okay. Questions? All right. So let's leave this running. So now to trigger it, this is why I really should have had 3 machines, because I'm starting to get. I'm going to open another terminal here, and I'm going to try dig. Dig. If this doesn't work, I'm going to switch the attack to the DNS server. So dig www.nathan.76.com. I did get the 8042. Do you guys see that? So I do get that. This generated also, see so this triggered it. That's good. Let's see the ping now. Ah, wow, for a change. All right, so this worked. Does it work for you guys? See this one, Nathan Technology 76. I get 8042. Does that make sense, guys? Making sense? Did some of you get this to work?
It worked for me.
Work for you? All right, great. Guys, we're there in the back. Sir, got it to work? All right, great. So at least this one worked. That's really it. I mean, you know, it's, as I said, we're not hacking DNS servers here. The whole point of this was to configure, bind, talk a little bit about network security, and just kind of look the flow of packets back and forth. Any questions? All right, so you should replicate this basically Okay, if you see here, that should be your screenshot that you need to have. Just mark it with red or something and an arrow and say 8042. That is the IP, you know, that I want it. Remember that doesn't exist and so on. All right, play with this. Try to make those happen. And then on Thursday, you can ask questions if you'd like. But we are, I'm assuming this would conclude basically our DNS discussion and sort of in, you know, in Linux. Any questions? All right, great. No questions, it seems. So this homework assignment will be due soft deadline Thursday night, and then hard deadline, I think it's like Saturday when it would close totally. All right, so please make sure to submit the report and you know what's should be included, okay? All right, great. So I'm going to then stop this. So there aren't packets running in the background. I'm going to do a clear here. That clear there. All right. So next thing we have some time is, you know, we are done with DNS. So let me stop this one. Stop sharing. Sharing. I'm going to